we will determine if an event is independent or dependent.
You all have your paper in front of you?
Yeah.
Coach Cruz is responsible for randomly selecting a captain and co-captain for the volleyball game to participate in the coin toss. There are 12 players to select from. Coach Cruz said that each team member has a 1 in 12 chance of being selected. Determine if you agree or disagree with Coach Cruz. Justify your thinking. Well, if there's 12 players to select from, and he's selecting a captain and a co-captain, I'm going to represent this. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 players. And so he says that each team member has a 1 in 12 chance of being selected. Well, the first time that he chooses a captain, there are 12 players. So the probability of selecting a captain is 1 out of 12. But now, whenever he selects the co-captain, one of these players has already been selected for captain. So now there's a 1 in 11 chance of that person being selected for co-captain. So,
Y'all see why she did that? Yeah, because so yesterday's independent events, they were events that did not rely on any other outcome, right? So today's, if they have 12 players and we were trying to select 2 different positions, well, they have to select one first, right? Okay, so we took that player out of the equation. So do I still have 12 players to select from? No, I had 11. All right? Because that just gives us our total probability. Okay?
I would disagree with this statement, and I'll let you explain in your own words that once one person is selected for captain, there are now 11 players that have a chance of being selected for co-captain. So the odds are now higher for being selected co-captain than they were for being selected captain. Independent probability is when the outcome of one event does not impact the outcome of the second event. So the probability of A and B is represented by the probability of A times the probability of B.
That's what you did yesterday.
Whenever the outcome of one event
Well, make sure you're writing.
impacts the outcome of another, then it is a dependent event. So the probability of A and B would be the probability of A times the probability of B after A.
Okay, that sounds a little confusing, right?
Why did you make
This
after
part.
A?
Because it's kind of like we did on that first example. Our second thing that we multiplied depended on how many things did we take away from the first one. Okay, so 1 out of 12 players, there's going to be 1 out of 12 players selected for the co-captain. Okay, that's what the probability of A represents.
Will it ever be like before A or something like that too? Or just
No,
after?
it'll just be after. Because it's like, okay, I've taken 1 away, or I've taken so many away from my possibilities. Now what do I have left? Okay.
So as you saw in that introduction, the probability of selecting the co-captain would change after they had selected the captain because there would be 1 less total player. Now, if you're following along with your student handout, find this example where we'll read each situation below and determine if it is an independent or a dependent event. So I'm going to work through these highlighted rows with you, and you can fill in the others on your own. A says flipping 2 coins results in 1 landing on heads and 1 landing on tails. Well,
What do y'all think?
Independent.
Do you think A is independent? Okay. Why?
Because
I didn't say anybody was right or wrong. Just want to know your thinking. Nobody's willing to say yet? Let's see what she says.
Isn't it dependent because
no, it's independent. I think it's
Why?
independent because
Why
if
though?
one lands on heads and the other one has to land on tails. I don't know.
it doesn't
It
land?
doesn't Because does flipping one of them depend on what the other one's going to do?
No.
No?
whatever the first coin lands on is not going to affect what the second coin lands on. So these events are independent from each other.
Because if I flip one and it lands on heads, does me flipping the other coin matter at all and why or how I did the first one? No.
And I'm just going to abbreviate there. C says you draw a joker from a deck of cards, and then you draw an ace.
That's dependent. No, that's dependent.
Why is it dependent?
Because it removes your chance of getting another joker.
Yeah. Okay. Because I drew a joker from the deck of cards. Okay, and then did I replace that? Did I put it back?
No.
No. So if there's 52 cards in a deck? So if there were 52 and I took one out, well, now there's only 51 cards left. So my probability changed. So it did depend on that first one.
Well, the problem doesn't tell us that the first card was replaced, so now we're assuming that we kept the joker, so there's one less card. So these events are dependent. The outcome of the second event will depend on the outcome of the first event. And E says a 3-digit password can be any combination of numbers. So because it can be any combination, it doesn't say that numbers can't repeat. So that means that the numbers can repeat, so these are independent from each other.
Y'all agree? Okay.
Great job determining.
All right. So let's look at the other two. This is B. Anita reaches into a drawer with necklaces and selects 2 to wear.
Dependent.
Y'all think it's dependent? Why?
It removes your
It
chance of
doesn't
getting
say that she takes it back.
Okay, it didn't say she put it back. She's trying to draw 2. So if I drew 1 and then I drew another, did it take that chance of that first one being drawn again? Yes, so it would be dependent. Okay, so D, you draw a queen from a deck of cards, replace it, and then draw a 10.
independent.
Okay.
Because
Because you drew one, which you said you wanted, you put it back.
This right here, when I replace it, that is a huge indicator of independent, okay? Because I did not take anything away from it. I put it back. Yesterday on y'all's homework and y'all's papers, that was there a lot, okay? So you need to think of replace as independent. Okay, so this one tells us straight away that these are dependent situations, okay? So it says, Neil goes to a pet shop and selects a treat for his dogs. He chose one and then chooses another. What is the probability that Neil selects a bone and then a ball? Okay.
It's 3 sevens for the bone and 2 sevens for the ball, and then you got to multiply it. You should get 6 over 49.
Okay. What do I always have to know when I start with probability? Like before I can do total. That is what I have to know first no matter what, right? So Will said 7. Do y'all agree?
Yes.
Okay, so there are 7 total. Well, there were how many bones?
3.
Okay. Now, so if I took one away, let's say I drew one was a bone. How many do I have left to choose from? 6. Okay, and then I have 1 and 2. So I have a 2 out of 6 chance there.
So it'll be 6 over 42.
Okay, so if I multiplied, I didn't cross cancel or any of that. Raise your hand if you like cross canceling, like you like to simplify before. Okay, so I know some of you do. I know some of you don't. So for those of you who don't, that's what you would have gotten. Can you reduce that?
Yeah.
By 6, okay? So that would be 1 over 7. Now, if you would have cross-canceled, all right, well, I could have reduced this by 1 over 2 because I could have divided by 3, okay? And that would have given me 2 over 14, which also reduces to 1/7. Or somebody said, well, I reduced the 2/6 to 1/3. Does that work also? Yes.
So every time you get the first number, you have to take 1 away.
If it's choosing 1, yes. Because remember, probability is something out of the total amount. Like, what is my chance of selecting this out of this huge, selection? So if I took something away, my total changed, right? So that's why we have to keep that in mind. If we always have to know our total, we also have to be aware, did my total change? Okay. Mackenzie chooses one candle and then chooses another. What is the probability that Mackenzie selects a polka dotted candle both times?
2 and 5 chance.
Okay. I have 2 out of 5, right? I have 2 polka dotted candles. So if I chose one the first time, how many do I have left total now?
4.
Okay, now I have a 1 out of 4 chance, right? Because I took one polka dotted candle away, right?
2 with 20.
Okay,
But then you're some fight.
So it goes to 2/20ths or 1/10. A lot of people said they liked this better than yesterday.
That's a lot of laundry.
A lot of laundry.
Still don't understand.
Y'all good?
How you got
Are we gonna go back to the video?
how you went
Okay.
from five-
Are we gonna go back to the
Okay.
video?
So I had 5 total, right? Well, I drew one and it was a polka dotted one. So now I don't count that in my total anymore. How many candles do I have? 4.
Yeah,
I also took one of the polka dotted away. So I have 1 polka dotted out of 4 candles total.
So you subtract 1 from the top and the bottom.
If it was that specific, yes. Okay. We good? Will, can you please stop touching the lights?
Are we gonna go back to the video?
The video, that's all the video did. Okay. So it says, read each situation carefully. Determine if the events are independent or dependent. So that is my first thing I have to do. I have to read my scenario. I have to figure out, are they independent or dependent? And then find the probability of the events occurring. So like we've already said, what do I always have to know before I can solve any problems? The total. Well, I need to figure out, it says she's doing laundry and has various pieces of clothing in her laundry basket. So what we need to think of this as is I just took a whole bunch of stuff out of the dryer. I put it in a laundry basket. We already know, you think of that. If you are trying to find something out of a laundry basket, it can be challenging sometimes, right? Okay. So we need to know how many pieces of laundry we have in the basket total. So we would count.
Is it socks just one or is it a pair?
No. If you reached into the laundry basket, can you just pull out one?
There's 16.
15. Oh,
It's a towel. Because the dryer doesn't fold your socks for you, does it?
no.
It doesn't match them up.
I wish it
So
did.
I
Yeah,
wish it did too, because I think my dryer eats my socks. So I could pull out one sock without pulling out another. Agreed? Okay. So this is, what is the probability of selecting a top and then selecting a bottom? Well, first of all, I have to know I have 16 pieces total, right? How many tops do I have? I only have one shirt, right? So I
Not wear shirts?
1 out of 16. Maybe they just, I know that my kids wear more bottoms than they do tops because they're sitting in the dirt. That, you know what I mean? You could have odd pieces of clothing. All right. What do you think my next fraction would be? So I've selected a top and then I want to select a
5
bottom.
out of 16.
How many bottoms do I have?
4.
5.
I have 5. 1, 2, 3, 4, 5. Okay. So I have 5. I do not have 16. I have 15. I took my shirt out of there. So if I took one piece of clothing out of there first, I would only have 15 left. Now I've had somebody ask, can I reduce that 5/15 first? Can you? What is 5/15 reduced to? 1/3. So I go 1 over 3. Is 16 times 3 way easier to multiply than 16 times 15?
Yeah.
Yeah. So now I have 1 times 1 and 16 times 3. Let's do it. 16 times 3. 48. Okay, was that an independent or dependent event?
Dependent.
Dependent. It depended on the first event because my total changed, right?
I got 48.
That's what we got.
So the top stayed at 5.
Okay, the top was asking, right here, this one, this 5, was asking for bottoms. Okay, how many bottoms did I have? I had 1, 2, 3, 4, 5. That's why I have a 5.
Why did you take 1 away?
No, because I selected a top the first time. I didn't select a bottom. We've got to really pay attention to what it's asking us, okay? So this is saying, what is the probability of selecting a striped sock, replacing it, and then selecting another striped sock?
Why would you even do that?
That's a very good question,
That
Xavier.
sounds like saying like grabbing a football, putting it back,
Okay,
like,
okay, but maybe if they were like they pulled the sock out and they were looking for the solid one, it was like, nope, I didn't want that one. So they put it back.
Bruh.
I mean, I've done it.
Socks are socks, just wear them.
You wear unmatching socks.
Okay,
Troy, what's wrong with you?
so how many striped socks did I have? Striped.
Oh, stripes.
5. What did that replacing it tell us what type of event it was? Independent. Okay, so if I replaced it, did I have to take anything away from my total? No. So if I am multiplying it by what?
Why is there an I with a semicolon?
I'll show you in a minute.
And I-
What? Okay, I had 5 socks out of 16. If I replaced it, did my total change?
Yeah, 4.
No. Independent. So I put it back.
Oh, yeah.
So my total did not change, right?
Well, you took one out and then.
I took one out and I put it back. No, I put it back.
So it'll just be 5.
Yes. Okay. And then I just multiply. Well, I have 25 over 256. Okay, so Cooper, the reason I put the semicolon is because technically these are our 2 answers. Because it wanted us to identify if it was independent or dependent and then the probability of the event. I just totally forgot up here. Okay, what is the probability of selecting the towel, replacing it? What kind of event does that tell us it means? Independent. Independent. We replaced it. Our total did not change because the total stayed the same. Well, I need you to leave the pencil sharpener alone. Okay. So I replaced it. My total is not going to change. Well, how many towels are there?
One.
So I have 1 out of 16. So if I replaced it and it wanted to know what is my probability of selecting it again? Well, if I put it back, times 1/16.
1 over 32.
1 over what?
32.
256. Guys, look right here. We did that math already. Right?
Wait,
So there it is.
so I have a question.
Okay.
Why would they grab the towel,
And then got
throw it back in there, and then grab it again?
I don't know.
Because Cooper
Maybe they were
made
trying to grab the
I didn't word the problems. But yeah, maybe, okay, so I have several different types of laundry baskets, okay? I have one that is like tall, so it's deeper and it's harder to find stuff in, right?
Yeah.
So say if I was looking for a shirt and I pulled out the towel, okay? And I was irritated and I didn't take it, I didn't leave it out, but I just put it back in and I did it again. So it's saying, what is the probability of that actually happening, that you drew the towel both
Why
times?
do we have to talk so you grab it again?
Not necessarily once you start digging.
You guys know
Like
how
3.
it is digging for crap.
3.
Yeah.
Dump
I
the
have-
towel.
No, I'm
Yeah,
scared.
but you don't.
I have 2.
If you don't
Guys,
dump it out, it
guys.
ripples.
Is every problem that we read,
Real
Yeah.
life.
is it realistic all the time?
No.
I mean, I've done that before.
Is one like
But,
for
like,
your socks?
Why do
and
we
for
need the
your
problem? Why do we
pants
need
for
a
your shirt?
Yeah, why do we need to know
I'm just-
I'm just saying. I mean, like, who's gonna do that?
You know what would be
Every time they
smart
do
to not
laundry?
lose your
Like,
stuff?
I don't.
But you're not
Pick
gonna-
one
you're
laundry
not
basket.
Oh, it's a towel and throw back in. There's no
So you're not gonna go among
No.
the baskets.
Pick a laundry basket full of
You're
socks.
me
Then
getting a
full of
shirt.
like another laundry basket full of pants and
4
another
and
one full of
32
shirts.
pants.
It would, Xavier. That's a
So
brilliant
you don't have to
idea.
wear socks.
It's a brilliant idea.
Yeah.
I like it. Okay, refocusing. What is the probability of selecting a skirt and a top, one choice after the other? Okay, all this did was word it so that it could trick you. Okay, and the last class let it happen. They got tricked.
2 out of 16 and 3 6.
So I want you to think. First of all, is this independent or dependent?
Oh, yes.
It's dependent. Okay, because did it tell me I replaced it? No. Now, so this is saying I selected a skirt and then I selected a top. That's what this means.
Well, it only mean one
They did
skirt.
one and then did the other.
Does it
okay.
only mean one skirt or both of them?
No, it says a skirt. A means what?
So we got
1.
over 16.
Okay, so how many skirts are in the basket? 2.
That's what I said.
You said 1.
I said.
You
did
said
they- I
one.
said, what?
Will,
I said, did they do like both of the skirts? And you said no.
I thought you meant at the same time. Oh, sorry. I misunderstood you, Xavier. Okay, so I selected a skirt. I had 2 out of 16, right?
Yes.
Okay, so if I cut my skirt out, what's my total?
15.
1 over 15.
Okay, so I have 15 total because I kept one of my skirts and I selected the top. Well, how many tops did I have total?
5.
Only 1. There's only 1 shirt.
1.
Okay, so I have 1 over 15.
1 and 1.
Now, somebody wanted to simplify first, and that was fine. They said 2/16 could go to 1/8. Absolutely, it can. And that is a lot easier multiplication. So I have 1 over.
240. What if you multiply the 2 bottom ones? Would you still take that answer?
Yes, but you would still have to reduce. 120.
Oh boy.
Okay, E, we are going to skip for right now. Okay. We're going to skip it. We will do it, but just not right now. Okay, this one. I want you to try this one on your own real fast, and then we'll talk about it because nobody got it right on the first try because they weren't reading carefully because it's not tricky. I'm going to give you a minute or two.
Wait, would the first one be like 2 over 20? Because like she said the first 2. And there's 20 desks, so there's 5 in each
Wait, but
row.
it says a pair, right?
Okay.
I'm stuck with
Wait, which one are y'all doing?
The E.
No, I said Skippy.
No.
5.
Wouldn't it be 2 over 20? Because like they're asking, the teacher's asking.
Do you see 2 over 20 there though? Do you see that as an option? Okay, so let's talk through the question. So she's assigning a seat as they come into class. There are 20 desks. There's 5 in the first row. Okay. She asked them, this is really, really similar to the first example with the co-captain and captain. Okay. So she asked them to find the probability that the first 2 people that enter the class are assigned a seat in the front row. Okay, so that first one, I had 5 out of 20 seats in the front row, right?
Yes.
Yes. Okay, so the person that came in, first person, they get assigned a seat in the first row, right? So we still 5 out of 20. We take our total probability. I have 5 out of 20, right? And every single one starts out with 5 out of 20. Yes? Okay. So the next one, so like that captain's position, I had 1 out of 12. But I took 1 player away and I took 1 desk or 1 position away. So, okay, so if I've assigned one of the 5 desks to 1 student, I would take 1 away from both. So 4 over 19. So who did it correctly? Maricela.
got it right.
Good. Not so bad. What do you notice that you have to be the most careful about? Reading it. Reading the question. Okay? All right.